All right, a couple of things before I got away. So, one is I apologize to all the Ignite talks. I asked Jeff if I could do an Ignite talk on this topic that's in my brain right now. And then this morning I realized there's no way I could do this talk with 15-second slide flips. So my apology. And he said, well, why don't you do it as a unstructured? So I feel like I'm cheating, but whatever. Second point I think I'm going to make is why in the hell is this guy talking about quantum computing? Right. And I hope you're saying that right now. I think there's two things. When in the early days of DevOps, 15 years ago, I remember going into CIOs and said, you can join a 3% club or a 97% club. Because right now there's a 3% club that's getting what this is. And I was right. I did the same thing about cloud. I believe this. I could be wrong, but I believe this is something, not to drop everything, but this should be on your executive's radar right now. Now, hopefully I'll convince you. If I don't, let me know, because then I'll stop giving this presentation. So from attention is all you need. T, right? The T in GPT, Transformer. There's a paper by Google called Attention is all you need. It was 5 years from that paper to ChatGPT. Look where 5 years is right now. And we'll talk a little about what the prediction of almost every player in this is saying is going to happen in 5 years for quantum computing. So every technological revolution looks slow until it happens. IBM, Microsoft, Google. I was at an IEEE quantum computing conference 2 weeks ago, and every one of the leaders of their quantum, make no mistake, IBM has been in it for a while. Microsoft is building a new type of chip. Google, there's a startup I believe is going to be the next Google, PSI, if I'm right, PsiQuantum they're called, all saying they're going to have 1 million fault-tolerant qubits. If you want to know what qubits are, maybe we can do an open space in 5 years. And that's the one that solves the supremacy problem. If we look at quantum in general, I'm writing a book about the history of quantum computing, so we got to start with quantum mechanics. In 1947, because of quantum, the transistor was made. Right? That's the original transistor. See how ugly it is? In 2016, that's the first commercial quantum computer by IBM. They call it Chandelier. Looks kind of ugly as well, both from like another planet. And so right now we're in what we call the sort of noisy immediate scale quantum. Like this is the only era I've ever seen where they actually apologize for the error, right? And this is just saying it's not working. It just ain't working. It's noisy. And again, there's a lot of reasons why, but they know what they need to do to make it work. So this whole sort of idea that it's not working, fine. Again, it's another technology where we get the technology that doesn't work, but we kind of know where it's going. And again, 2030 is this tipping point where we start solving the kind of problems that literally were unsolvable. I'll give you some examples. Like here's one they use quite a bit. And again, I'm not an expert here. I'm learning like a fire hose, right? Penicillin is like 45 atoms, 176. On a classic computer, basically, to do an accurate simulation of penicillin is never, right? And you know, in this sort of noisy, in this cube, ever a demo simulation possible. Quantum supremacy, the fault tolerant 1 million qubit, weeks, right? And it's not me. These are like genius mathematicians in quantum mechanics, physics. In 2019, Google did something. They called it quantum supremacy. It was sort of bullshit, but it wasn't, because what they did is they took one of these hard problems. There's like these 10 hard problems, right? The traveling salesman, you probably heard that's one of them. They took this. It wasn't travel salesman, but it was something like that, and they estimated that it would have taken 10,000 years to solve this problem with the class. And when I say classic, I mean supercomputer too, right? I don't just mean like, large mainframes or a gazillion computers. And they did it in 200 seconds. It made a lot of press. It was like, and then all the real heavyweights were like, that's kind of, because it was a fabricated chip. It was, they did a lot of gaming of it. But the point was the algorithm was real. And now if you do Google this PsiQuantum, this is like, just watch the founder of this. This is a shipyard. This is an old metal shipyard or iron out of Chicago. They're literally building this massive quantum. It's all refrigerators. I mean, it's like they're like your new racks are refrigerators. In fact, the running joke in most of the people who sell quantum solutions is like, yeah, I'm a glorified refrigerator salesman. But like they're, and by the way, NVIDIA, you would think, oh, well, what, NVIDIA would be scared of this, right? No more GPUs. No. They have these things, they call them QPUs. So what you're going to have is these circles of CPUs. So classic computing ain't going away. Your ingress and egress to quantum algorithms are going to be classic. And there's a lot more into why, but so NVIDIA loves this story because they're just going to build, in fact, what they're doing with PsiQuantum is their assumption is there's going to be a gazillion GPUs circled around a bunch of QPUs, the quantum process units. Some of you who've been following this a while, I know Jeff has done this. Gene has talked about this. What's his face? No, I get terrible at names. Wrote a whole book about Carlota Perez, these sort of like they call the technological revolutions of financial capital. It's a brilliant paper. And it talks about these revolutions that happen. And there's sort of an installation period and a deployment period. And we've used it a lot in like revolutions. And the idea is when financial capital moves. It's not the invention itself. It's when the financial capital moves. And I'll give you some examples here. The transistor was great, but it didn't change the world until people put TVs in their house. That's when, in sort of Carla Perez's, that's when the financial capital moved. The internet was out for quite a while. It wasn't until Andreessen and those folk created a browser, right? AI has been, for those who got my book, thank you. If you read it, it's about 100 years of solid work. And in fact, 1946, I think, was the first neural network paper, right? And it wasn't until ChatGPT that it became, you go back 6 years ago, 3% of the educated in the world were using AI. Now probably 30% of the world is using AI directly, right? And I believe there's what I'm calling this going to be a ChatGPT moment in quantum. I don't know what it is. It's probably going to be around optimization. But again, that's a fight. If I'm right, and IBM and Google and Microsoft and a lot of the players, if they're right, we're going to see a chat. And everybody thinks it's going to be encryption, and that's a problem. But here's the thing, like if you're an organization, this is what I want, like you can either say, John, you're full of shit, get out of here. Or you can say, I need to talk to my CIO about this because, the question, if I talk to a CIO and say, are you worrying about quantum? I'm like, yeah, John, I got that. We're dealing with cryptology. We know that this is a scary thing because they've proven logically that you can break RSA encryption. If they can finally get a computer that's fault tolerant, they've pretty much proven the algorithm could break. There's something called Shor's algorithm, right? But like that, I'm not going to go in JP Morgan Chase and tell the CIO, like, get out of here. Like, I know that. But what I am going to say, there are these hidden risks of not getting involved. And like I said, I don't want you to drop I don't want you to drop everything and like, let's change everything to quantum. I'm just saying that if you don't start planning it within this say we're in the GPT-1 era right now, and 5 years will happen like that. And if you're not sort of dealing with some of these hidden risks, well, so here's the quantum story. This gets most of the oxygen. It's called harvest now, decrypt later. That's what the adversaries are doing, right? Like they're figuring this is going to happen. I'm going to store all this data. If in 5 years from now, that data is dangerous to your organization, you're in big trouble. But the real scary ones are the companies that are investing right now in talent and really start thinking about, like, how do I solve problems? Start thinking about the kind of problems, the way I think about using cloud or I use agentic. Let me start adding a little bit of resources onto how I use quantum to start thinking about problems. And then talent, that crystal ball idea. Like how many people got caught by surprise by ChatGPT? Not necessarily that everybody was using it. It was that your organization was like, what are we doing with this stuff? Right? Where do we hire people? And then what did the salaries do? They went like skyrocket. Well, it's going to happen with quantum. And it's going to be worse with quantum because nobody can explain quantum. Richard Feynman, who basically invented quantum computing, says his quote is, if you think you know quantum computing, you don't know it. Right? It's going to be really hard to hire people. But here's the one that scares me the most. And I was talking to an airline yesterday. Like, when you start talking about quantum computing and optimization, there are going to be a slew of patents. So imagine in the airline business, the first person who writes a quantum algorithm that figures out the most efficient way. When you're landing a plane, there's a lot of economic principles in that, like how much fuel do you mean? Do you have to circle around? What is it's a very, very complicated algorithm. So imagine that you could imagine you're an airline that gets a patent on that optimization. Guess what all other airlines are going to have to pay, right? And these and optimization could be as simple, and I know I'm getting crazy, is how to do incident management at a massively large bank. I mean, I don't know that's the way it's going to play out, but like if those things start turning into patents, we got disruption. Everybody knows Nokia. I mean, again, I think if your CIO is basically ignoring this or don't worry about it because I got quantum-proof people down the hall, I think there's an argument to wake them up and say, well, maybe we should pay a little more attention to this. And, so like start a literacy program, get people sort of, especially your younger people or your talent pipelines, right? Start rolling them in, right? Funding sort of, and not so much security, because if you're a bank, you got a security. There's a quantum team running on security. But like optimization and simulation are going to be two of those hidden risks. And then I, sort of love this, like technologies, going back to the Carlotta Perez, technologies are maybe invented in the lab, but the revolutions are made in the living room. There will be a chat GPT moment, and you will be, if you ignore it until when that happens. So like my point is, if you had a crystal ball in GPT-1 era, what would you have done or would you have waited for chat GPT? Anyway, thank you.